All right, this is 11-4, two-way tables, part 2. You conduct a survey. Of course you do, because that's what we all do in our off time. 286 students in your freshman class. Notice they keep on saying freshman and sophomore. That's because they think that you're in high school. And you pretty much are. Okay, so you asked 286 students in the freshman class whether they play a sport or a musical instrument. Okay, once again, how do we know we're kind of headed towards a two-way table? We have one group that we're asking, freshmen, and it's two different categories. Do you play a sport or a musical instrument? 118 of the students play a sport, and 64 of those students play an instrument. Ah, interesting. 93 of the students do not play a sport or an instrument. Organize the results in a two-way table. Okay, so I kind of already did this for you, right? We've set up the idea that we have sport, yes or no, instrument, yes or no, and it says 118 of the students play a sport and 64 of those students play an instrument. So that's kind of yes, they play a sport, and 118, yes, they play a sport, and 64 of those students play an instrument. So if you play a sport and an instrument, you're one of the 64. So yes and yes, here's the 64. Now notice it also says that there are 118 who play a sport. So that's a marginal frequency, the 118. That's all of the yes sports people together. The 64 is a joint frequency only for the people who both play an instrument and a sport. Next sentence, 93 of the students do not play a sport. Okay, 93 do not play a sport or an instrument. So that means no and no, 93. And then we're going to organize the results in a two-way table, and we needed to include the marginal frequencies, which are kind of already happening. Okay, so we know where the 64 came from. We know where the 118 came from. We know where the 93 came from. Where does the 286 come from? And here's where it comes from. If you have all of the students who said yes to playing a sport and said no to playing a sport, you should have the total of that column is everybody who was asked, which is the 286 students. And you could get there both by the column or by the row. If you get all the students who said yes, they play an instrument, and all the students who said no, together, if you add those from left to right, you're going to get the 286 people who are asked total. The cool thing is once you have these joint frequencies and this marginal frequency, well, and this one too, the total, you can fill out the entire table. So now all we have to do is we need to look at if 64 said yes and 118, there were 118 total, then we take 64 from 118 and we get 54. But now we also know how many people said no to playing an instrument, right? We can get this marginal frequency because we can do 54 and then we can just add 93. So that's 7, and then 9 plus 5 is 147. And you can see how this is all starting to come together like a Sudoku puzzle. So now we can figure out how many people said yes total by taking the 286 total and subtracting the marginal frequency of 147 who said no to playing an instrument. And you get, was that 139? If I make a mistake, just bear with me. Okay, so if there were 139 people who in total it said yes, and we have 64 who also played a sport, then we can just take 139 and we can subtract the 64, and what was that, 75? Okay, and now all we need is the marginal frequency for the total number of students that said no, and so it's just 75 plus 93, which is 168. Okay, so now we've filled out the table based on the things that we were given. And that's really what you're going to be doing in this section, is a lot of that kind of stuff. And I should say, before I go on, you can check whether or not these numbers make sense. Add 118 plus 168, is that 286? Yeah, it is. And so you can check to make sure everything is correct. Okay, so now we're going to move on to the next example, where we're going to learn some new vocabulary. I'm sure you're so excited. Oh my God, you guys are so awesome. Okay, now these look a lot like what we've already learned. Joint frequency, marginal frequency, but now that has the word relative in there. And relative means compared to something else. And so let's see what we're comparing to. the joint or a joint relative frequency is the ratio of a frequency that is not in the total row or not in the total column, not to the total number of values or observations. Okay, so before we move on, let's just go to an example because otherwise it's going to freak you out. This is just a regular two-way table. It doesn't actually have the marginal frequencies, but we were just told that that's not what we're looking at anyway right now. We're not looking at the marginals. We're just looking at the joint frequencies. Okay, now the two-way table here is we have a class, either juniors or seniors, and we have a major in a medical field, or are you going to major in a medical field? The people who said yes and the people who said no. Okay, two-way table shows the results of a survey that asked college-bound high school students whether they plan to major in a medical field. Okay, make a two-way table that shows the joint and marginal relative frequencies. Okay, well, the thing is what we need to know is how many students there are total, and I don't think it says it here, so I'm just going to tell you right now, there are 680 people who are asked. Wait, I don't know what just happened right there. There are 680 students asked. You could figure that out from the information given to you in the joint frequencies, which are all these, right? If you add these together, you get some number. You add these together, you get some number. You add those together, you're going to get 680. Now, the joint relative frequency. If there's 680 total students, what we're going to do is we're going to take the joint frequency, which is 124, and write that as a ratio over 680. When we divide that, we get 0.18, which hopefully you remember D2P. We can convert this 0.18 to a percent. That's 18% of the people who are asked were juniors who said yes, they're majoring in a medical field. Okay? So now the 101, if you have 101 seniors who said yes, you write that it's a joint relative frequency. So it's not just the joint frequency, which is 101. It's the joint relative to everybody frequency. 101 divided by 680 is 0.15 or 15%. Same thing goes with the 236 divided by 680 and you get 0.35. So that's 35%. So now if you're finding the joint relative frequency, you start with the joint frequency, which is just the raw number, 219 people who were juniors who said no, they're not majoring in a medical field. And you write that relative to the 680 students who were asked. And this one I can't do in my head. So I'm getting out my calculator. And that's approximately 0.32. Those are approximates. I don't know why that came out so poorly. Okay. So we now have the joint relative frequency of juniors who said yes, that's 0.18 or 18%. The joint relative frequency of juniors that said no, that's 0.32 or 32%. You could do the same for seniors. Okay, you probably know where this is going. The marginal relative frequency is the sum of the joint relative frequencies in a row or a column. Well, now that's just like the old marginal frequency where we added together the joint frequencies. But now the marginal relative frequency, we're just going to add 0.18 plus 0.32, and you happen to get 0.50. That number is not special. It could have been anything. But that means 50% of the people who were asked were juniors. 50% of the people who were asked were seniors. Okay, now what is the marginal relative frequency of people who said yes, they're majoring in the medical field? If you add together the joint relative frequencies, you get the marginal relative frequency, which is 33%. Now we could probably derive what this is just by doing 100% minus 33%. Not a big deal, right? 67%. But just to see that that doesn't work out perfectly because these are approximates. If you find the marginal relative frequency, which is this one on the margin, by adding together the joint relative frequencies, you get 0.67. Oh wait, never mind. That worked out perfectly. What am I talking about? It won't always work out perfectly since we are estimating here. But 0.33 plus 0.67 is 1. In other words, 67% of the students said no, whether they were senior or junior. Okay, that ends part Oh, I forgot to say this real quick. When finding relative frequencies in a two-way table, you can use the corresponding decimals or percents, which I've been doing. Anyways, that ends part 2 of 11.4 two-way tables. I'll be back for part 3.